Hey guys, in this chapter, let us try to understand what DevOps is, why we need it, and the day to day activities of a DevOps engineer. To understand anything, we first need to understand the problem and how it is solved. So, to understand what DevOps is, let's start by understanding the problem it addresses and then see how it provides the solution. So, without any further delay, let's get started. Let's rewind to about 10 years ago and see how software development used to work. Back then, the process began with planning, where product managers and stakeholders listed the features and requirements. But developers were never involved in this phase. Once the planning was done, it was then passed to the development team. In this phase, developers would spend weeks or even months coding based on those requirements, but they rarely thought about how that code would eventually run in production server. All they used to focus was whether it was running on their local machine or not. After coding, developers would manually compile and package the code. This step was prone to human error because it was repetitive, tedious, and one small mistake could delay everything. Once the code was built, the QA team would manually test it. Since all testing happened after development was complete, bugs were often discovered late, leading to delays as developers struggled to fix those issues. Please note that up to this point, operations had no clue of what's going on, and releasing software was a big deal. Code was released in large batches all at once, which increased the risk of failure. If something went wrong, it could break the entire system, causing further delays. And next comes the deployment phase by the operations team, who had never involved in the development process. That is the reason they had to struggle to understand the infrastructure needs, such as CPU and memory requirements. Once the deployment was complete, developers would often step back and relax, leaving the operations team to ensure everything ran smoothly. But unfortunately, operation folks were not familiar with the application because they never involved in the development process. Lastly, monitoring was usually not a priority in traditional software development. It was reactive rather than proactive, meaning if something broke, it could take days to figure out what went wrong and even longer to fix it. In summary, in the traditional development approach, there were two main teams involved in delivering software: the development team and the operations team. The development team was responsible for writing and testing code. Once their job was done, they didn't worry about how the code would be deployed to production. And the operations team used to handle tasks like managing servers, scaling systems, ensuring security, and taking backups. They used to focus only on keeping production running smoothly with a little involvement in development. This approach led to several issues as both teams worked independently with minimal communication, leading to incompatibilities between development and production environments, causing delays in releases. Also, deployments were risky and prone to failure due to manual steps. Feedback from production took days or weeks to reach developers, slowing the response to issues. These problems created bottlenecks that slowed down the entire software delivery process. Because of these problems, organizations needed a more collaborative and integrated approach where both teams worked closely from planning to monitoring. And that's where DevOps come into picture. Please note that DevOps is neither a tool, software, nor a programming language. It's a culture or a mindset that bridges the gap between development and operations teams. By adopting DevOps, developers and operations work together from the start, ensuring smooth deployments and better understanding of infrastructure needs. Manual and error prone processes like testing and deployments are automated, leading to faster and more reliable releases. Shortened feedback loops allow for quicker fixes, improving software quality. Now that you understood what DevOps is, let us see how the DevOps culture differs from the traditional software development. During the planning stage, developers, operations, and even business teams come together to collaborate. They discuss not only features but also infrastructure needs, timelines, and potential bottlenecks. Tools like Jira and Confluence make planning transparent across teams. Once the planning is complete, developers get to coding with the big picture in mind. They understand that their code must run on production servers, not just on their machine. They collaborate with operations early, writing infrastructure ready code. They use GitHub or Bitbucket to host the code and tools like Chef or Ansible to ensure the code behaves consistently across all environments. As developers finish coding, the CI/CD pipeline automatically triggers a build. No manual effort required. The build system ensures everything is packaged correctly. Tools like Maven and Gradle help in this step. In DevOps culture, once the code is built, automated tests run immediately. There is no waiting until end as in traditional software development. Unit testing, integration testing, and even performance testing happen early using tools like Selenium, Karate, JUnit, and SonarQube. This way, bugs are caught early and feedback is faster. After testing, automated pipelines deploy features incrementally with no downtime. Releases are smooth and often go unnoticed by users because they are so seamless. Tools like Jenkins, Argo CD help with continuous releases. Also, deployment is now an automated, effortless process. Using CI/CD pipelines and tools like Docker and Kubernetes, deployment happen multiple times a day. Once the software is deployed, the DevOps culture introduces the principle of you build it, you run it, meaning developers are more involved in the operational side. When something goes wrong, they work closely with operations to resolve it. Tools like Terraform, Chef, Ansible help manage infrastructure as code, ensuring smooth operations and faster issue resolution. After deployment, the real-time monitoring is set up using tools like Prometheus, Grafana, Tempo, etc. so that the team knows what's happening in production at all times. Alerts are triggered automatically, allowing the team to act before users notice an issue. Both developers and operations share responsibility for uptime and monitoring. In general, a DevOps engineer ensures automatic building, testing, and deployment. He works closely with developers and operations to streamline deployments. Also, he sets up the real time monitoring and handles the production issues. In summary, DevOps transforms every stage of SDLC through collaboration, automation, and continuous feedback, leading to faster, more reliable software delivery. This shift creates an agile, efficient, and scalable process, drastically improving the traditional SDLC model. This is just beginning of your DevOps Zero to Hero journey. In the upcoming videos, we will dive deeper into the tools and processes that make DevOps possible. Stay tuned. My name is Pavan Elthepu and thank you very much for watching this video. If you enjoyed the content, please share it with your friends and do not forget to subscribe to my channel to not miss any updates.